Previously, dense versus Mo-E. Today, quantization, the single most important optimization for fitting models on edge hardware. Starting with the basics. Quantization is simple in concept. Model weights are numbers, normally stored using 32 bits each, full precision. Quantization stores them using fewer bits, 4 bits, 8 bits. Same model, smaller representation. The memory math is direct. A 12 billion parameter model at full precision needs 48 gigabytes. At half precision, 24 gigabytes. At 4-bit integer, around 6 gigabytes. 8 times smaller. Same model. Why this matters for edge. A consumer GPU like the RTX 4060 has 8 gigabytes of VRAM. A 12 billion parameter model only fits at INT4. Without quantization, edge LLMs don't fit consumer hardware. The common misconception, quantization makes the model dumber. Wrong. It's the same model. Each weight is stored with less precision. The quality cost is real, but often minor. That surprises engineers. Quantization, fewer bits per weight, massive memory savings, quality loss smaller than most assume. Next segment, the actual spectrum of precision options. Previously, what quantization is. Today, the practical spectrum. 3 precision levels engineers actually use, with real numbers per model size. FP16, half precision, 16 bits per weight, the native shipping format. The 4 billion fits in 8 gigabytes. The 12 billion needs 24. The 27 billion, 54 gigabytes. INT8, 8-bit integer, half the memory of FP16. The 4 billion drops to 4 gigabytes. 12 billion to 12, 27 billion to 27. Quality loss is usually negligible. INT4, 4-bit integer, quarter the memory of FP16. The 4 billion drops to 2 gigabytes, 12 billion to 6, 27 billion to 14. This makes larger models realistic on consumer GPUs. The hardware map. A phone with 8 gigabytes runs the 4 billion at INT4. A RTX 4060 with 8 gigabytes runs 12 billion at INT4. A RTX 4090 with 24 gigabytes runs 27 billion. 3 precision levels. FP16 is native. INT8 is the safe drop. INT4 makes edge deployment realistic. But what does INT4 actually cost? Next segment, the quality trade-off. Previously, the precision spectrum. Today, the quality trade-off. How much quality does INT4 actually cost? The honest answer surprises engineers. Quality loss is real. INT8 typically holds about 99% of FP16 quality. INT4 typically holds around 95 to 97%. There is quality loss, but smaller than most engineers expect. Where the loss shows. Edge cases and rare knowledge fade first. Long, complex reasoning chains get less reliable. Precise numerical answers lose accuracy. For routine tasks, the difference is nearly invisible. Here's the real insight. Compare 2 options on an 8 GB GPU, the 4 billion at FP16, the 12 billion at INT4. Both fit, which gives better quality. The 12 billion. The bigger model wins, even with quantization loss. Why this matters for edge. You have a fixed memory budget. Spend it on a larger quantized model, not a smaller full precision one. That's the engineering insight. INT4. Real quality loss, but smaller than feared. The bigger model at INT4 beats the smaller model at full precision. Use the precision your memory allows. Next, when each precision wins. Previously, the quality trade-off. Today, the precision selection framework. When to use FP16, when INT8, for concrete criteria. Pick FP16 when memory is abundant and quality is the priority. When you're benchmarking against the reference. When deployment is a workstation or server with plenty of VRAM. The quality ceiling. Pick INT8 when you want safe quantization. Roughly half the memory of FP16, with quality loss usually under 1%. When deployment is memory constrained, but quality cannot drop. The safe middle ground. Pick INT4 when deploying to edge hardware. When you need maximum memory savings. When you want a bigger model than would otherwise fit in VRAM. This is what most edge LLM deployments use today. For edge deployment specifically, INT4 is the default. INT8 is worth measuring if you have headroom. FP16 only if quality is truly non-negotiable. Pick the precision your hardware allows. Quantization. Real engineering math. Real precision decisions. That ends episode 5. Subscribe to follow the series. Episode 6 next, setting up Ollama in Docker, where we get hands-on. Recap: INT4 for edge, INT8 for safe savings, FP16 when quality is non-negotiable. Match precision to hardware.